is the one that has its vertex on the circle as well as its endpoints. So what you see in blue on my screen, that's called the inscribed angle. The arc that it goes to is called the intercepted arc. So we just discussed how the measure of the inscribed angle is half of its intercepted arc, because if you were to draw central angle here, it's going to be half of that central angle. Okay. Here's a couple things that we could look at. So a couple ways that you're going to see it. The angle goes through the center, or it's on the outside of the center, or it's on one side. Okay, we're going to find some angle measures. What we're looking at is, again, the inscribed angle is half of the arc that it intercepts, meaning the arc that it goes to. So if I want to find measure of angle T right here, the arc that it intercepts is arc RS. It should be half of that arc. So what's the measure of angle T going to be? 24. That's good. Okay, next one. If I want to find the measure of QR. Okay. Right now we don't know, it doesn't give you an inscribed angle to go that. But let's look at could you look at, please, angle QRT? So angle QRT, that inscribed angle is 50 degrees, which means that you should be able to find the arc that it intercepts, this one. So what's that arc going to be? 100, double. So if we know that arc is 100, if you look at RT, RT is a diameter, and so that means that you have a semicircle. So this entire thing from here to here would be 180 because it's a semicircle. So what is QR going to be? 80. Okay. Next one says find the measure of the minor arc RS. So RS corresponds to angle U. RS would have to be double. What's RS? 62. So measure of arc RS is 62 degrees. It also asks you for the angle measure of STR. So that would be this one. What arc does STR intercept? SR, same one. So what is the measure of STR going to be? 31 degrees. It's going to be the same thing because it intercepts the same arc. So that's what the theorem on the very back says. Given that the measure of angle E is 75 degrees, find the measure of angle F. Okay, measure of angle E intercepts this arc. What arc does angle F intercept? The same one. And so since they both intercept GH, then their angle measure is going to be the same. So measure of angle F is 75 degrees. Because they're going to both be half of that arc, which happens to be 150. Okay, last thing. If you have an angle that intercepts a semicircle, so it intercepts and goes to a diameter, like this arc measure would be what then? 180. And so what does the inscribed angle here have to be? 90. Makes sense? Okay. Next theorem is about quadrilaterals. Bless you. It says that the opposite angles have to be supplementary, which means they add up to 180 degrees. So these two, F and D, would have to add up to 180. G and E would have to add up to 180. Why? Does that make sense? The opposite angles have to add up to 180. How come? Reese, why? Because of what? So this angle, F, corresponds to this major arc here. And this angle, D, corresponds to this minor arc. Why is it that these two angles, the blue and the red, why do those have to add up to 180? AB is a diameter, so you know that this arc has to be 180. This is a right triangle then. What does that angle have to be equal to? The angle is going to be equal to 90, but you'll solve and get x. So since that has to be a right angle because it's intercepting 180 degrees, x is 45 degrees. Okay, and the last one, quadrilateral. Opposite angles have to be supplementary. So you should write two equations. One, z plus 80 equals 180. And another, y plus 120 equals 180. Here's the thing. You could add up all of these and set them equal to 360. It's not going to help you, though, because you can't solve for two variables at once. So z would be 100, and y would be 60.